welcome to this lecture number 10 in our 12+1 row of lectures on introductory statistics. Today, as you may imagine, we're going to take another big step out into the future. We're going to go from 2 to more than 2 when it comes to comparing means with each other and quantifying differences between means. That's basically the purpose of today. The plan looks like this, split in the middle. And we started the introduction. This is, I'll look at the kind of data, and if with a bit of luck, I'm going to share some TV data with Bang & Olufsen for you. I ran into some installation issues again, but let's see what happens. Here is the little toy data exemplifying the purpose of today. The purpose is to be comparing the means between the three groups A, B, and C. And had I only had two groups A and B, this would exactly be what I taught you on 2-sample t-testing quite some weeks ago. So this is the generalization of the 2 independent samples t-test to multiple groups, and then next week we'll do the generalization of the 2 paired samples t-test actually next time. And funny enough, the name, this is the first thing to get used to today, funny enough, the name analysis of variance is still the name for a method that has as a purpose to compare 3 means with each other. So it's a bit funny name in the first at first view. At the end of the day, hopefully you'll realize that it's not a completely ridiculous name, apart from the you could have chosen to call it in a different way. But this is in a way how it was named, and we stick with the name because everyone else in the world used that name. It is a standard assumption here, as we've seen a lot, that we have normal distributed data. So we'll have a look at how to check for that once again. No, not major news there. And then the other introduction was just to say that kind of multi-group mean comparisons is really being used a lot, many places out there. I was planning on bringing an example. This is a picture from Struer at the Bang & Olufsen site. It's not a brand new picture, as you can see on the TV screens that they're testing at this occasion. These 32-inch, very, very expensive TV sets are already outdated by other developments. But that was what we were working on back then. And we developed tools in our research projects together with Bang & Olufsen. The research director, the research manager of Bang & Olufsen is an engineer from here with a background in audio, and now he is part-time professor at Aalborg University, working with experimental psychologists and others in developing product development within the hi-fi business, sound, video. You use humans to evaluate, to verbalize sound and vision quality. You cannot just do engineering and high-tech measurements. If you want to have find products on the market that are designed to work for human beings, you need to think about how human beings actually perceive those features that these products are supposed to give to us. That is pleasure, enjoyment by means of visual and audio stimuli. And that's a pretty hardcore psychological research field to be on top of how to actually do such things and measure it and be on top of how that actually works in the pretty complex thing that we humans have on top of our bodies. So that's a pretty interesting place where engineering, psychology, everything meets up, business, marketing, product development. Everyone meets to make good business, and still they are doing business there. Let's hope they will continue for some while doing that. Let's see if it works for me now. To just show you, otherwise I'll show it to you here first, because I'm gonna dig into TV dataset actually on such TV screens that are shared in a package openly. This is a package we've developed in a research project with Bang & Olufsen as one of many partners, was part of that research project. The first author of the package is a former PhD student of mine. It's a very nice package that adds on the opportunities in R to actually do such more complicated types of analysis of variances that we will not get to at this course, but we will begin now. And even this one you could use for simple settings also. So I'm gonna dig into a data set, and then I will zoom in a little bit to make it sufficiently simple for it to make sense within the tools that I will share with you today and next time. So first of all, I am going to, there is actually 3 TV sets in this data set, like we see here. Actually 3 different TV sets here. We don't see the difference really, but they are different. And then the thing about testing products within the audio and visual stimuli business is that you cannot test a TV without actually putting something on the TV. So you need to, there is a pretty seriously business about how to define the stimuli to have a good evaluation of the TV screen. So in this case they have 4 standardized stimuli. We see a bird picture here, but they have other standardized stimuli to evaluate the TV screen. So we have 3 TVs by 4 different picture types. That makes 12 different products. If you were in the food business, these would be the products you were considering developing. And then you ask people to score the noise level, how they perceive all sorts of things on these TV screens, and you usually have a number of people doing that, and you have them repeat the thing to have sufficient stableness and exactness in your results. And the whole purpose of this, one of the purposes is to compare the TVs with each other and find the TV with, for instance, the lowest level of noise level, right? And other features. So the whole analysis making you able to do such conclusions is based on comparing mean scores of various features on these TV sets or TV by picture situations. Let's see if I will succeed. I can do 2 things. I can see if I managed to have our package installed. Something is working. Let's see. It didn't work here. I'm gonna have a look at that. You can play around with this yourself. I'm sure it works for you. It's something about administrative rights on my computer here. I would like to show you actually that we developed a piece of open source software apart on top of this R package that everyone can use and find. Let's see if we can make this work then. Here's my little personal computer here. I have the panel check software up and running here. You can go, if you Google panel check, you can download that on your computer. It's a kind of Python-based, nicely working software, very easily used. It has some R routines running underneath that people don't need to know about, because this is for practical use, and this software is being used in all sorts of companies around the globe. One place, Bang & Olufsen, Arla, you name it, where they use this for the so-called sensory data that you get when you use humans to actually score your products and to do product development by using human panels. If you can, it's a bit small, but you can see 8 assessors, attributes. There is a noise attribute somewhere, and then the samples, the products, are the 12 combinations of the TV and pictures here, 3 TVs and 4 pictures. And then you can see one of the results here is that you can get some analysis of variance results in these data here, for instance. And now I'm gonna go back to the basics because you are not quite ready for this, but at the end of this course you are pretty close to be ready for what they're actually using in the business out there and that we developed for them. It's just to let you know that the methodology here is not just an art methodology, it's something that is actually being used quite a bit out there. So I may run to an issue here later on, but no, that's going to be actually nice, because then we'll go down to my toy data. To that we can control. Now I don't need my fancy package and all to do my toy data. Back to this. Here's my toy data. 3 groups of data, just 4 points in each. It could be 4,000 data points in each, but here there's only 4 in each. And I'm just depicting the simple data, and then the box plot is a bit much with the box plot of 4 points, but generally the box plot is a nice way to show the data. And the purpose is to actually compare. Should we try to actually export? Copy to clipboard. Copy plots. Let's see if it works. Let's see if it works. Whoa! Let's see. Here we are. So the whole purpose is to compare the means of these 3 groups. I just throw in the 3 means here. That would be the first mean, the second mean, and the third mean. The question is basically, are the underlying true means, are they the same or not? That's the question we are going to answer by the general analysis of variance method. That's what it's all about. And these are the code I just used to prepare the plot that I just showed you. That was the intro part. So that's what we will be doing. And we will be gaming also today. That's the fun part of it. Yeah, I just found actually some of my projects in the data bank for students here, just to let you know that we are still working with the Bang & Olufsen people, and there is a project there right now with some methods that we're going to develop with a bit more modern version of the Bang & Olufsen products and not the old ones. Anyway, let's go to the fun part. Let's see, my Cahoots. Play. Classic. I'm a classic guy. Bit of music. So, we're a bit fewer people today. Maybe some people have a deadline in mind. I'm ready. Let's start. Are you ready? Please, good. Please appreciate my improved visibility of those outputs, right? Good, thanks. Mellow Mike is in business again. Good.